Welcome to Flat Earth Debate Live. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe. Hit the bell notification icon and join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate. If you would like to support the channel, there is a super chat that runs alongside each of these shows while they are live, and there's also a PayPal, Patreon and crypto link in the info box below the video. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel, so please share the show on Facebook and Twitter. Now, before I introduce all of our guests, I'm going to say a quick thank you to all of the people who've supported my GoFundMe campaign. So a massive shout out to all of you who have supported the campaign so far. I don't think I have as yet in this live stream put a link to this, but I will. So I'll grab that link and stick it in the live stream chat as the show is going on. But if you have supported it, massive shout out to you. Greatly appreciated. With that, I'll say a huge warm welcome to Mitchell from Australia, 10th Man, Eli, I don't know where John's gone, but massive thank you to John for disappearing right while I was doing the intro, and a warm welcome to everyone in Discord as well. Welcome, one and all.
Morning.
Good morning.
Good morning, guys.
Good afternoon.
Hello.
Good evening. Yep.
Good morning, good afternoon, good evening, wherever you may be. Good to have you all. Thank you for being here. Any evidence of a physical geometric sphere-edge horizon, formerly known as the curve of the Earth?
Definitely not. Not since January 1, 2020, anyway.
Oh.
Hello, I'm back.
Hello. Any evidence that you can acquire an elevation angle from a curved baseline?
No, impossible. Section is an angle measuring device. It needs two straight lines meeting at a common point to form a vertex. You must have a baseline, and you must minus it from 90. So how in the world do you get a right angle triangle on a curved surface? Impossible.
Yeah, it must be a flat baseline, flat horizontal baseline. That's what they keep telling us.
Hey, Mitchell. See you.
Hey, Owen, how are we, mate?
Feel good. I just wanted to be stick in the mud again and say, like, look, dude, when you're using an optical instrument, you know, light's actually going to be bent, but it works out because eventually things that you are measuring are going to present themselves like a flat plane. So it doesn't actually have to look like a globe for the instrument to work, right? It doesn't have to work through the geometry and the straight line versus the globe, because effectively, if you're using an optical instrument, everything's just straight. You're just using that flat plane, a seeming optical flat plane. That's all you need.
How does the protractor base being level help you with that argument?
I'm sorry, I don't understand.
Start the show yet?
Well, at least that was.
Were you saying something about Were you saying something about a bent line?
Yes, he was, yeah. Mitchell's just tweeting what's going on.
So, I understand how this works, but I just want to pick your brain a bit, Baldwin, if that's what you're playing at the moment.
All right.
What kind of refraction are we using? Like, is it refraction to an object? Or is it refraction to a celestial object?
Mitch, I almost did a little sound effect with your first question. You've immediately won. That's why there was a pause. Don't just chill. Let him answer. Feel free to ask again because I've interjected.
What sort of refraction are we using that, Arwen? Baldwin?
Refraction based on the radius value derived from the equator length of Earth.
Oh, that's a shame, isn't it? Because we get the radius from the elevation angles with a flat plane. You need a flat Earth for that.
Well, that's what we thought at first before we discovered terrestrial refraction.
You still got terrestrial refraction. So when you discover terrestrial refraction, where's your R come from? Do you have to discover the R too, which you can't achieve without that flat Earth
You
baseline?
can still achieve it. You just can't measure it optically. That's the problem, right? But we can still derive it from equator length, right?
But you got he's already covered that. No, you're not gonna, no, you're not going to dosey-do him round. You've already covered that. He's just covered
Yes,
it.
I
Elevation
am.
angles to polarity. He's already covered that, Arwin. Come on, be reasonable.
I'm sorry. Who's this Arwin you're talking to?
Oh, right. I'm going to do shout-outs. I'm sorry, Mitch. You beat him twice. The fact that he's now going to snap into, well, I can just rinse and repeat 5 times. I'm not going to allow it. You won. You beat him. Yeah, terrestrial refraction derived from an R value you either get from elevation angle measurements to Polaris or from a geometric non-horizon that's refracted. Yeah, you're not getting R to give us a derived value. You can't measure it. You already conceded that. He won.
That's a
Can we move
straw
on?
man.
Can we
Both
move
the
on?
examples you gave, I did not use. I said derived from the equator length, right?
Yeah, where do you think
That's
that came from? He covered it. Let me just shout
From
out
the
these super chats.
celestial lights above us.
Oh, God. Let me just shout out
Yes.
these super chats, then you can take it up again with Mitch if you want to do that. Shout out to Paul Connell. He says, big shout out to Arwin's Flat Earth Early Bird Show. Woohoo! Indeed, you do. Subscribe today, ARWIJN. I'm honoured to receive a wrench today. Thanks, Arwin. Oh, isn't that sweet? And thank you for the super chat, Paul. Really appreciate your support of this show as well. Hopefully you super chatted Darwin. Shout out to Godzilla37 who says, shout out refracted. Thank you very much, both of you. Really appreciate the support. Right, yeah, feel free, Borwin. You have it out with Mitch if you want to carry on this nonsense. Terrestrial refraction. that needs
Good morning, guys.
Right. It's
Chocolate.
just like, oh, you always have to, flat earthers always have to straw man the ballers about, oh, you derived it from Aristophanes. Yeah, we know, Aristophanes. It's doesn't account for terrestrial refraction, right? And the horizon, yeah, we know it's not geometric, right? That's the inherent problem of terrestrial refraction. But we can still derive it from the overall equator length, which are again derived from sun positions and all that. So there's still something we can hold on to in order to establish the radius. You just can't really measure it using visuals anymore.
Third time's a
Okay,
charm.
So when you say,
Go on, Mitch.
so why are you still going with terrestrial refraction? Is we're using a sextant here, an angle measuring device. Is when we correct the refraction after using the sextant, is that terrestrial refraction we're correcting, Baldwin?
Well, that depends on what they're going to end up with specifically, right? As far as I know,
Doesn't depend.
The surveyors actually use the locally flat plane system, so they don't really have to account for terrestrial refraction bending everything into that flat plane. They can just think of it as a flat plane, so they only have to account for actual refraction, which is technically almost insignificant, but you still have to do that if you want to be perfectly accurate.
Surveyors are using sextants now, are they?
Hold on, forget the sextant bit. He just mentioned about them using flat planes. Focus on the major bit.
I was trying to go in a
Seeming
totally
flat
different
planes.
direction.
It's
What do you mean
seeming
seeming
flat,
flat? Yeah,
planes,
so-
not actual.
Yes. So it looks flat, so we have to treat it as flat.
Measured flat. What do you mean treat it as flat, seeming flat? It's measured flat.
Yeah, but that's the seeming part, because when you measure it, you use optics, so it's basically seemingly flat.
Yeah. Sorry, as Baldwin, Arwin, do you not
Yeah.
feel embarrassed that your current rhetoric is to basically just agree with us? Because even it took a few moments for Mitch to even recognise that you were being a baller with these arguments, because essentially all of these arguments are you telling us how flat it is.
No, I'm ascending above that contemporary flare of victory that you may have just because things in your mind are as they seem.
As
Right.
measured.
That's the whole-
What's this as they seem? No.
They're
Measured.
measured using visuals. You
Yeah.
didn't. You didn't.
So
put
we're
a
looking at
ruler.
it, measuring
You
it,
didn't-
and it's flat. And you're saying, well, just because we look at it and it's measured, it's just how we're looking at it. Yeah. None of that helps Ball at all. I know
You
that's
didn't
their
put a
rhetoric at the
ruler
moment.
to that flat plane, did you? You just measured it visually.
What flat plane? The one that's supposed to be a sphere?
Yeah, exactly.
It is a sphere. It just
How
seems
do you
like...
know that? Did you put a ruler to that?
No, you can't.
Oh, okay.
So it doesn't seem very bally. It seems very flat. It doesn't measure very bally. It measures very flat. But you're clinging on to the, well, that's just because it looks that way and measures that way. Doesn't mean it's not a ball. That's crap.
Yes.
I mean, that is their rhetoric at the moment, are we? No, I appreciate you've not got much to work with.
That's true.
Yeah, but it is what it is, you know? We can't use optics to measure things because optics does not account for terrestrial refraction.
Meanwhile, we do use optics to measure stuff and then we build stuff. Or we do use optics to measure stuff and then we navigate. So while you might just decry how these things are actually done, they are done on a flat plane using optics, I'm afraid, Arwin.
No, that's just locally.
Did you
Just
hear
locally
what
flat.
you at the end?
Buildings are
Did you
not
hear-
so big that they all encompass the horizon. They never are. Buildings are never like so big that they'll get to your horizon, right? So they just use the locally flat mechanism, just like surveyors.
Thanks. Welcome to Flat Earth.
Locally
Yeah.
flat.
So flat then, yeah, thanks. This is what we're getting from the opponents. That's why they are more thin on the ground than they've ever been. Because to come here and try and argue celestial navigation means that they have to, somehow, weasel in a sphere in a flat Earth process. That's the long and short of it. Any evidence of axial rotation of the Earth-based variety?
You need a flat plane for that too.
I'm sorry, I still don't see how I didn't win that argument as well.
Yo, what's up, Mitch?
Hey, chocolate.
Maybe tell us how you did win it.
Well, it's simple. I basically made you realize that you can't use optics for the measuring of Earth, right?
No, wrong. You told me that, insisted maybe as a baller that was the case, when I then pointed out that we do measure them and we do navigate the surface. So what, just completely McToon syndrome, right? Just stick your head straight in the sand, pull it out again and repeat the same crap. Like
No.
what I said didn't matter. Yes, we do
No, you
measure it
seem
that
to
way. Yes, we do
misunderstand.
navigate it that way. Yeah, we do exist on a flat plane and we have to deal with it as such. That's a fact. You saying, well, it's just optics. No,
No.
the buildings, the stuff on the surface, Arwin, the navigating of it, that's all done with a plane. That's just how it is.
Yeah, but it works fine because of the locally flat system, right? As long as it's measured with rulers physically and water level and all that plumps, right? As long as it's measured flat, then yeah, the architecture has no problem. But yeah, if you're gonna put it on the wider, can I finish, please? Flat Earthers always interrupting me, right?
You're interrupting him. You're interrupting him, telling us how flat it is to be able to build stuff. My bad, Arwin and Baldwin. Sorry.
Meow, 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 meow. Meow, meow, meow.
Please continue telling us how flat it must be, Arwin. Go ahead.
Yes.
As Baldwin.
Right. Yeah. It only has to be flat locally, right, with the architecture, because otherwise you're going to have bent architecture, which is very difficult to achieve. So it's locally flat, but on the wider scale, you know, when you're looking at the horizon, there's always going to be the optics factor, and that's where terrestrial refraction actually comes in. So on the wider scale, you can all treat it as if it is flat, but technically, if it's big enough, it's not flat anymore.
You can't,
Terrestrial refraction applies.
Please. You're just rinsing and repeating. This was covered 10 minutes ago by Mitch. So no, if you're using terrestrial refraction, then you're going to be deriving it from either elevation angle measurements or a measurement to the physical geometric sphere edge horizon, as per Al-Biruni, neither of which are open to you. Terrestrial refraction leaves you with a paradox that you can't fulfill. You need to get and measure an R value to claim terrestrial refraction, and you cannot. And any measurement that you do claim will come from the same methods that we use with flat Earth to get them. So when we do get them and do claim them as sphere, and then point out that they've come from a flat plane, you say it's just optics. Yeah, but you're using the same things to then claim it's a sphere, Arwin. So you've got
No,
nowhere to
I'm
go,
not.
and we've already covered this.
You keep strawmanning me with
Oh,
these
God.
outdated arguments.
Let's
We
bang
don't
up to date.
consider the horizon
Bang up to date.
geometrics, and we can't use optics to determine terrestrial refraction. Stop strawmanning.
No, you can't use optics to determine terrestrial refraction because it's a mathematical derivation of an R value that did use flat Earth optics to get.
Yeah, sure.
Yeah. Right, let's move on.
Thanks.
Any evidence you can have gas pressure without the necessary antecedent of a container to press up on, and shout out to Godzilla37. I'm not going to miss any of his super chats, goddamn. Gas pressure without a container, you're going to need a flat tyre for that. What? Thank you very much for the super chat, Godzilla.
Well, technically, you don't need gas pressure without a container because the second law of thermodynamics doesn't apply to the atmosphere.
Atmo what now?
What atmosphere?
Atmo
Yeah.
what? Atmo what? Atmo
That
means
sphere
air.
part?
Air what?
The gas that surrounds the ball Earth.
The ball Earth that you literally just told us has to be measured flat. That one?
Only optically measured flat.
Oh, only optically. Okay.
Right, but since gases are invisible, it's not really relevant whether the Earth seems flat or not in order whether like the atmosphere, whether terrestrial. I'm mixing up here. Whether second law of thermodynamics applies to that. Like the visuals are not relevant to that.
Air's not a sphere shape.
Yeah.
There's no sphere shape to air. Air, inhomogeneous, anisotropic mixture of gases that are unbonded, don't arbitrarily form sphere shapes. They take the shape of their container, not the shape of a sphere arbitrarily because you've got a sphere Earth that you've just told us comes from flat Earth measurements in all respects.
Yeah, but fluids have a downward factor, right? Vector. There is no problem. Gases don't expand in all directions.
But gas is not liquid.
No, not liquid, fluid.
Yeah, you could use fluid to describe gas and liquid, but gas is not liquid.
Well, it's not that hard to overlook that part.
Oh, sure. We can just overlook that. Okay, Baldwin.
Okay, so gas is not going down, go boom, boom like solid bonded bouncy balls. Again, gas is expanding to fill its containment. It expands in all directions, all vectors. It does not go down, go boom, boom. Now, equivocating this gas in a hypercompressed state and calling it a fluid, and then saying, well, I can describe it as being a bit like liquid when I hypercompress it. No. Number one, that's not how gas is existing in nature. And number two, gas in any state will expand in all directions, all vectors. That's what gas does. It's gas behaviour. Ergo, if the sky was a vacuum, that would be a vast availability of space. Oh, what do you know? They call it space, don't they? Well, then the gas would fill that space because it expands in all directions to fill the availability of volume it has, as per the second law of thermodynamics, aka entropy. Any more on this subject?
Could electrostatics create a containment field?
Do you want to show me gas pressure without a container, Arwin?
Electrostatics makes gas go down, go boom, boom?
A high pitched at the end because you're asking it as a question of me?
Yes?
No, gas does not go down, go boom, boom.
Surely you must have a demonstration of this, and I'm still waiting for someone to give us a demonstration of gas going down, go boom, boom because of electrostatics.
Well, it's a bit
Demonstration?
difficult because, gases tend to be kind of invisible, so I can't really show it to you.
Red herring anyway. The question is whether or not you can have gas without containment. The antecedent consequent relationship that is gas and gas being in a container to have pressure, showing a violation of that, to show that it's possible in any way, shape or form. Throwing out a red herring in terms of whether or not electrostatics can achieve that, it's like maybe they can. But can they achieve it without containment? Because that's all that matters, because there's a claim that there's a vast area of space, called space, that's an area of volume for our gas that we all breathe to fill. We're breathing high-pressure gas. So how do we have gas pressure? Well, what's the antecedent-consequent relationship to have gas pressure? Containment. So we must be contained. What's that they say? Oh, no, there's a vast area that we could just travel out to as astronauts. No, that's a complete lie and violation of natural law. Who cares if electrostatics or whatever can make a gas do something? It doesn't make any difference. Unless you can show without containment, because that's what's claimed to be the sky vacuum from the heliocentric priests.
I'm sorry. As Baldwin, I only understand atmosphere dynamics.
But there isn't any atmosphere. There is no such thing as atmosphere. It's an oxymoron. Air is not sphere-shaped. Any scientific evidence of gravity, as we're talking about gas go down, go boom, boom?
No, still need a flat plane for that.
Well,
Flat plane for
it
what?
depends on what you think gravity really is, you know?
As to what
Flat
it
planes
is?
is
You would think at this point we would know what it is, being that it's like the whole heliocentric model is based on that. So why don't you know what it is, Baldwin?
Well, you know, the problem Newtonian mechanics has been very handy to basically provide a playground in order to set up the heliocentric model, but it's already been admitted that it technically doesn't exist. And yeah, the alternative so far has been kind of conceptual and impossible to physically prove in any way. So yeah, what do? You know, we're still like Newtonian physics dependent, but yeah, it's kind of worn off. It's like we got this band-aid that worked really well, but it's kind of disintegrating, you know? We got to find some kind of gravity soon. Otherwise, this heliocentric model is going to be like too outdated.
Well, let me know when you find that. Meanwhile, while I hold my helium balloon that's trying to go up. Thanks.
Another shout out to Godzilla37. He says, Richie believes this money is wasted, but he also believes he's on a spinning wet ball rocket. So who cares what he believes? Thank you very much indeed for the super chat, Godzilla37.
Yeah, just pick your gravity, whatever the flavour of the day is, but we just want scientific evidence for it. Doesn't matter what sort of gravity you're asserting. Just give us scientific evidence.
Okay, but we have to.
Well, he already conceded he doesn't even know what it is. If you don't know what it is, I mean, first you'd have to have an observation of it. So then what? You have an observation of something you don't know what it is? Or you don't have an observation at all?
Any single viable hypothesis from any of the fields of astronomy, cosmology, or astrophysics?
Well, they would have to have them. Otherwise, how would we be able to use email and laptops?
That's technology, not science.
Baldwin, does science prove things?
That depends on who's asking.
Chocolate's asking.
But Nathan, that housekeeping question directly refutes gravity right there.
Which one? Yeah, you're right. If you ask for a viable hypothesis and they haven't got one, then they wouldn't have one for gravity.
For
right?
astrophysics, yeah. Mm-hmm.
You did just ask Arwen a good question, though, Chocolate.
The science prove things, Baldwin, sorry.
Right. Well, that depends on who's asking.
Nah, the scientific method doesn't depend on somebody asking a question. Definitely not that. I just want to know, does it prove things?
Was that a nod to science buddies, Arwen?
Sometimes, yes.
Was that a nod to science buddies? Ask a question. Depends who's asking is kind of a... Was it a subtle nod to science buddies? The like top result if you ask what science is to Google.
That's kind of what I heard too, yeah.
Right. Well, no, but it also in discussions it matters. Like, what is the inquiry, right? What is the science about that's supposed to be able to prove
Oh,
or
okay.
disprove?
Well,
something?
you can take that as read because of the arena, right? We're dealing with the physical and natural world. We're talking about the nature of the world, most specifically. So when we talk about science here, we're talking about natural science.
Okay, well, that doesn't really prove anything, right? It's only the science that applies to widely recognized models like the atmosphere when it proves things.
Okay, let's just establish our Baldwin's position. Baldwin saying natural science doesn't prove anything. Feel free, Chocolate.
Because it's always changing.
Your name's
remember?
not Chocolate.
Sorry, I got a coworker talking to me. Give me a sec.
Need one of those little banners that says intermission.
I got an elaboration, right? Why
sure you
doesn't
have.
natural science prove anything? It's because things are always changing. But things that don't change, like the model of atmosphere, that's actually quite stable. So science does prove things concerning that because that model never changes.
What an outrage.
The nature, however, and our understanding of it is constantly changing.
No.
So what we thought was proving something before might turn out not to be proving something afterward because we figured out another model that rearranges the entire scenario.
Give Chocolate another couple of seconds, and if he doesn't respond, I'll rip that to pieces. We'll see how Chocolate goes.
What I'm basically saying is that only the science of models proves things.
What an outrage.
Not good. Guys, go ahead. I can't talk for a few
That's
minutes.
all right. Okay. So no,
I take your
hypothesis.
concession.
No, is Owen going to rumpus me now? No. When you establish your cause of an effect through systematic experimentation based on a hypothesis, you have validated the cause. There is no changing the cause. If A, then B. Once you've established that A causes B, it will never be any different. Ergo, you prove things with science, Arwin.
Yeah, but what if other factors are different, though?
Then you
Then
didn't-
it might not work like that anymore.
Then you didn't isolate an independent variable. If other factors were a contribution to the effect being induced, then you didn't isolate an independent variable. Ergo, you
What
didn't.
if there-
Ergo, you didn't adhere to the scientific method, so your methodology would be flawed. That wouldn't be the fault of the method, science, or the fact that it proves things. That would just be your ineptitude when it came to following a method.
But what if you can't isolate a variable because you don't know it exists? And you misplace your understanding of the variable onto the thing you're trying to very manipulate.
Yeah, okay, I heard. Science has got you covered with a null. So you're saying you've got a phenomena, something's occurring, and you're trying to figure out what causes it. And you don't know. Now, at that point, you don't necessarily appeal to it not existing at all because you know the phenomena does occur. You just haven't figured out what caused it. But that would be if A, your presumed cause of the effect, not B, you vary it and it doesn't cause it. Well, that would be you proving the null. You validate your null hypothesis. If A, not B. You proved that to be true when you vary that which you assumed would cause the effect and it did not. So science has got you covered. No matter what the outcome, if you have performed a hypothesis test, that would be an experiment in scientific vernacular, you always, without exception, prove the null or prove the alternative. Okay? So you will be proving something if you're doing science.
Right? But it's still going to be based on current moment understanding, right? Because in the future,
No,
the
it's not based on current understanding. It's based on manipulation of a presumed cause of an effect to see if you can cause it, not on current understanding.
Yes, it is. So,
No,
for
it is
example,
not.
if you introduce heat with water to make it boil, right, which is considered science, well, what if in a later stage heat is not considered as it was before, right? What if heat actually is defined as something else? Then the original hypothesis no longer is true.
No, that's untrue also. Whenever you formulate a hypothesis, everything that you define within that hypothesis must be defined rigorously. There is no ambiguity in terms of what you're discussing, detailing, varying, and manipulating. It's all tied down. So there is no ambiguity. You have to be hyper-specific about what you're doing and what you're saying and what you're going to be performing. More importantly than anything, the semantics of what you vary matters not. Only that what you vary, your independent variable, that which you assume causes the effect, is varied and does cause the effect. That's all that matters. How you term it is irrelevant.
Hold up, okay.
I disagree.
Wait, did you just say that maybe one day we might redefine heat?
Yes.
Oh, okay. That's ridiculous.
He hasn't got much to work with. He's saying science doesn't prove things, a la anti-flat earthers. So what's he got to work with? Science, matter of fact, proves things. In fact, it's all it does. If you perform the method, all you do is prove something. Either if A, then B, that would be an alternative hypothesis validation, or if A, not B, that would be a null hypothesis validation. So validation in both instances, you're proving something either way.
Right.
But it's only going to stay in a certain way if it's a model, and that model isn't changed, because our physical understanding of physical reality does actually change over time. So even though you've defined something rigorously within the experiment setup, it might later turn out that the very thing we thought it was that we were manipulating isn't actually that. And so the entire model, which it wasn't because it was natural science, is then disintegrated. And that's why science doesn't prove anything unless it's a model.
Sounds like you got a faulty model.
Models
Hold on.
aren't science.
If science,
On John.
I was going to say, then there's no point in doing science because you can't prove things false either.
Exactly.
So
Now
no point in doing science.
Yes.
That's ridiculous.
Maybe.
Yeah, that's where anti-flat earthers are at. Well summarised, Borwin. Reasonably concise as you can be when you're denying that science proved things when it's advanced humanity with the method of proving things. Just ludicrous.
It
but
is
that's what they
really
say.
difficult to argue that. I agree. It is really difficult.
But they do, because they've been tricked. They've been tricked into believing that pseudoscience stories made up about lights in the sky, along with second law of thermodynamics violation sky vacuums, is quote-unquote science. That's what they've been told. So they've been told science is in flux, science can change at any time, and it's just not true. Natural science is a method of establishing cause and effect. That's it.
It's a hell of a switch because science used to prove the globe, according to them. So what the hell happened there?
What happened was we exposed that what they said was science and what they said was proving the globe. Number one wasn't science and number two wasn't proving a globe. And upon finding this out from us, they told us science doesn't prove things.
Well, they say that science only disproves things now, but that's still proving something false. So it's nonsensical, the statement that it just disproves. They don't know what they're talking about, and that demonstrates that they don't know what science is when they say things like that.
Any evidence of a self-perpetuating molten iron core at the centre of a presupposed spherical Earth?
Every time that's brought up, the baller in me is kind of embarrassed because there's just so little actual leads to that, you know? It's like the least talked about assumption of the entire model.
Hey, Sleeping Warrior.
Yo, yo.
You
Any evidence of the R value, Earth radius?
Derived from equator length based on celestial maxim.
And flat Earth elevation angle measurements?
I got told that Blue Marble Science measured the R value, and I asked him, well, how did he do that? Because like I know that the deepest hole ever dug is like about 11 kilometers deep, 7 or 8 miles, whatever it is. And he said he did some shadow work and did some sums. And when I pointed out to him, that's not measuring, is it? That's calculating. He wouldn't accept it. He thought it was quite acceptable to calculate indirectly. He could indirectly calculate, and he thought that was credible.
Hold on a second. Hold on. John, did you want to take this up? Did you say you took some shadow angle measurements?
Yeah, that's a big Eratosthenes proof of a flat Earth right there. How do you work the baseline into being curved and get an angle?
It's the whole point about calculation that it is always indirect.
Hold on, before Baldwin hijacks this, did you pick up on what John just said to you, Sleeping Warrior?
No, I didn't have a chance to process it. Say it again, John.
Well, when he measured an angle using Earth as his baseline with his shadow cast on the Earth and the angle that creates, he curved his baseline to assume Earth was a sphere, but he measured it flat.
See, no, I think that's.
Do you understand now, Anthony? Do you follow what's being laid out?
Yeah, but I think it's a non sequitur fallacy because
no. Quite the contrary. What this is you and I will. You entered Flat Earth a little bit later than me, but nonetheless, you were around when I was being barraged with sticks and shadows, right? And then as we progressed through the argument, we realised that they're inserting R. You following so far?
Yeah.
Inserting R into what, Anthony?
The maths.
What's the maths?
Well, 7 over 6R.
No.
15,
no, sticks and shadows. We're talking about sticks and shadows. So you're saying, I'll just take you through it. I'll hold your hand because I want the audience to understand this. It's very important. So they insert R into maths that they've taken. So prior to the R insertion, what have they measured, Anthony?
Well, they've measured an angle.
And how did they do that?
Well, they got the shadow or the well, whichever, and then they measured an angle with a straight vertical, and then they measured it out with a straight angled line, and then from there they made some assumptions. So
what you're saying is this process is as follows. First, measure angle on flat plane. Then...
See, no.
Hold on, you're disagreeing with me like I'm wrong. Go ahead, Anthony.
I think that's a non sequitur fallacy because just because you're measuring an angle, it doesn't have anything to indicate the shape of the Earth. You're just measuring an angle.
When you're measuring a baseline, an elevation angle, specifically an elevation. What's an elevation angle, Anthony?
Well, it's 2 straight lines that has got nothing to do with... The map is not the terrain. The angle is not the terrain, is it?
What's an elevation angle? Not an angle, an elevation angle.
An elevation angle is the adjustment made for being above the surface of the water.
That's dip correction.
Oh, sorry. The elevation angle is the angle that's measured between the target star at the horizon or planet or sun. So it's using a flat baseline, but the baseline isn't the land.
So if I define it as, quote, the altitude angle, sometimes referred to as the solar elevation angle, describes how the sun appears in the sky. The angle is measured between an imaginary line between the observer and the sun and the horizontal plane the observer is standing on. End quote. Sustainable by design, altitude angle definition.
Yeah, you wouldn't say that's a
plane. Horizontal plane because it must be in order to measure an angle, Anthony.
Is that horizontal plane physical or is it imaginary?
It's the horizontal plane you're standing on and measuring an angle from.
So you're taking that as an admission that just because it says a horizontal plane, that therefore means the Earth is flat?
It can't not be, because if it wasn't, you wouldn't get an angle, Anthony.
Yeah, but just because you think that the elevation angle represents the terrain doesn't make it so. I'm still just measuring an angle.
Until you build on it and navigate it. Then you can pretty much say that everything you're doing with the surface when measuring these angles on a flat plane is relating to the surface, how you build on it, and how you move about on it. So while you might infer that, well, just taking an angle, if I was just standing there with the sextant, you can't then infer that the ground is flat. Well, no, I can if I take an elevation angle measurement to 3 stars and then move around on the surface. or I establish a horizontal plane that they sometimes describe as a tangent plane and then build on it, then I can say it's flat because I've utilized the fact that it's flat to measure an angle and then move around or build on the flat plane that I just measured because I measured it and then moved on it. Simple.
Hold on. He missed something, though. He said it was a non sequitur. But your baseline is the Earth. That's where the shadow's being cast. In
No.
shadows.
The baseline is just a line. An angle is just two lines meeting at a point. So when it's a horizontal plane, that angle, that line, is just an imaginary line in the same way that the imaginary line to the target for the elevation angle, that's an imaginary line too.
Hold on. But where is that line corresponding to in reality?
Well, it's either the target or the horizontal plane.
Yeah.
Exactly.
And where is the horizontal plane? Is that the shadow or is that not an angle?
Is that a stick or the shadow? Which is
just an imaginary datum point, so we can measure an angle from it.
You're measuring something. Anthony, stop saying it's imaginary.
It's parallel
when you physically
to
measure.
the land.
Hello. Stop saying it's imaginary. There's a measurement being taken, isn't there?
Yes, there's a measurement.
Right. So why do you keep saying it's imaginary?
Well, because you need two straight lines for an angle, and it says that the first one is an imaginary line to the target. So the second one must also be imaginary too.
No. That definition was in regards to an elevation angle measurement to the sun. This is just a stick in the ground, though, isn't it?
Okay. What's your point then?
So we've got two lines, one of which is a baseline. Is it the stick or is it the shadow, Anthony?
The baseline is an imaginary line, isn't it?
No, you measure it. We're going round in circles.
Listen, Anthony, what are you standing on? Imaginary line or the plane?
Where's the shadow?
It doesn't matter what I'm standing
is the shadow on an imaginary line or is it actually a shadow on the ground? Your baseline.
Your shadow is a line, isn't it? It's an actual line.
Right, finally. So we're measuring something. Their measurement, Anthony, must have a flat baseline, just geometrically. It's a fact. To do this and then insert R, regardless of your telling us that it's an inference, well, that inference that's taken with a flat Earth elevation angle measurement to get the angle is then taken as read geometrically to be flat to then insert R. So as much as any fundy might come and say, well, no, you can't infer the ground, well, you do. You measure it flat, the ground, and then take that ground measurement with a flat baseline to insert an R value. So they take it to be the ground, Anthony, which they later bastardise and bend with R, after measuring it.
The non sequitur fallacy, just because you assume that it's a flat plane doesn't make it so.
No, Anthony, what you're doing is what the ballers are currently doing. They're using a bubble sextant for the artificial horizon that they imagine at their eye line, which must correspond with the Earth they're on, because when you use the marine sextant using the horizon, which is the Earth, you do dip correction and get your eyeballs on the surface of the water. Those are two parallel lines. So you can do it both ways, but it must match the real Earth when you do dip because it's parallel to the real Earth. So you're describing the bubble sextant with an artificial horizon, which they call the sensible horizon, which is the horizontal line emanating from their eye line. But when you use the horizon, the actual Earth, you do height of eye correction to get to the surface, which must be parallel because they both work with the same methodology. You must take the elevation angle, then get the zenith angle, divide that by 60, and then you get, multiply that by 60 and get your nautical mile distance. So you're on.
May I ask Anthony a question?
In the same way that a map is not the terrain, the angle is not the terrain either.
Can I clear this up? Go on, John.
I just want to ask him, do you think that an angle exists between the end of the shadow and the top of the stick?
Yeah.
Or do you think that's just a, what'd you call it, a non sequitur fallacy to assert that exists?
Well, the angle only exists if you measure it, right?
Right.
If you don't measure it, then there is no angle.
Okay. So there's an angle there using a flat plane,
Yeah.
But there is no angle to the sun.
Using two straight lines, not using a flat plane, using two straight lines.
A flat plane.
Yeah, that's
How do you have a straight line on a
line.
sphere?
Can I clear this up? Anthony,
Yeah.
do you realize that they have to use the GP of the sun, which means the ground position or geographical position of the sun? That's what the
No, I'm
well
just
is.
measuring an angle.
No,
Hold on,
one second.
let's go back to the
Now,
question.
No. Hold on,
One
Brian.
second.
Brian, we've gone on to sticks and shadows. Just hold that thought
That's
for a
what.
minute.
That's what. I know that. I'm trying to explain it.
I want to do the same,
well-
Brian. It's just John's trying to do it with sticks and shadows, and I want to try and focus on that. I want to say
But
that
I'm
too,
talking
5,000
about
miles in that direction.
I'm talking about Eratosthenes. I said well.
Oh, my bad.
Anthony, they have to use the well, right? He's using the well where the sun is over, where there is no shadows, and that well is 500 miles away. So
Yeah.
the baseline of the angle has to move. It has to be stretched along the surface of Earth.
Yeah.
The baseline, right, has to stretch along the surface of Earth for 500 miles. It's a right-angled triangle. It has to be straight. It won't work if Earth is curving underneath it or anything like that. It doesn't work. It has to be straight. So you're measuring 500 miles along the surface of Earth from you, the observer, to that well, to the GP of the sun. That's a straight
I don't have
line.
a problem with that.
But you can't do that if the Earth is curved.
The problem is though, the moment you start reflecting comparing the angle to the terrain, that's when the fallacy is committed, because it doesn't naturally follow that the angle represents the terrain. It's just an angle.
Yeah, but you're not worried about mountains or hills. You're making a horizontal baseline using the surface of Earth for 500 miles. You can't do that.
No, not using the surface of Earth. No,
Yeah, you're
it's using an imaginary line.
Hold on, Eli. When you say no, not using the surface of Earth, yes, that's exactly what's happening.
No, it's just an angle. It's just two imaginary lines.
Yeah,
It's
along
not the terrain.
Anthony, in that demonstration or claim to be proofsy, that is what is being done. Now, you can argue and say, well, to reify the angle between you and a well that's got a sun directly above it, that's not the land. Okay, fine. However, it is claimed to be measured as the land, Anthony. Ergo, this is a flat Earth proof, and if it's claimed to be a globe proof, then the first step must be accepted as a straight, flat baseline along the ground for it to be a valid angle measurement to move forward and insert R. So both. Let me finish.
Say it again.
Just let me finish. So, you and me don't have to agree that that reified angle as you describe it proves anything. No, but it's claimed to be an angle measurement that has been taken. And when that was taken, for both sides at this stage, it is matter of fact geometrically measuring a flat plane. It can't not be, it's an angle measurement. Now, beyond that, they then take that flat Earth angle measurement that you're denying and say, we'll insert into this absolutely established, perfectly flat angle measurement along the ground and insert R into it, or derive R from it. Yeah? Well, it matters not whether or not we argue about whether or not you agree with that angle measurement that is claimed to have been measured. That is a flat Earth angle measurement, whether you like it or not. Okay?
It's still only an angle.
Hold
It
on.
doesn't represent the terrain.
No, see, the shadow part directly ties it to the ground. Because where's the shadow at, Anthony?
The shadows at the ground.
Yeah, so that's your baseline of this angle.
The baseline is just a line. It's not the ground. The reference point might be, but the line itself is still an arbitrary line that we call an angle.
Okay, I think you're missing the
so
point.
you cannot.
Okay. You're missing the point.
Your point is. No, his point is to say that you can't measure an angle between the tip of the stick and the end of the shadow, and that's just not true.
No, that's not my point. My point is that when you measure your angle, it bears no resemblance whatsoever to the ground below it.
So it's not using the shadow.
I can measure an angle off the back of a turtle's tortoise shell. Does it mean
No, you
that's
can't.
No,
does
you
it mean
can't.
that that's a
No, you
perfect
cannot.
line because I've measured up?
No,
Okay.
you
Does it mean that
can't.
it's a level?
Stop. That's incorrect. So you believe that the curved surface of a turtle shell meeting a straight line will give you an angle. That's incorrect.
No, the two lines that I use to measure the angle from above the turtle's back, the measurement of the angle with two imaginary lines, that's what gives me the angle. The turtle underneath has got nothing to do with the angle measurement.
Now you've got the shadow that's formed on a curved shell being an imaginary line. No, there is actually a shadow. It's forming a curve across a curved surface. That won't give you an angle, Anthony. Second time I've said it.
So
Anthony, for this to work, there has to be parallel zeniths. You can't have divergent zeniths. That means that the surface has to have a horizontal baseline. There's no
Mike
way around
Jones
that.
says it's just an angle and you can do fuck all with it. Oh, really? Well, it's claimed to be an angle that's then utilised with an R value insertion after the fact to claim Earth's sphere. So the sphere has taken this angle and turned it into a sphere surface, Mike. So while you might decry this angle measurement, globe Earth is based on it, and as is a factually flat Earth angle measurement that they have taken and then used to bend into a sphere. You don't have to like it, you can deny it, but that is their rhetoric. They measured it flat first, they can't not have, they wouldn't have got an angle to then add in R afterwards. So whether or not you like it is irrelevant, Mike. Thank you for the super chat, though.
Well, that's the thing. With Anthony just admitted that the shadow is on the ground and you can measure an angle between the end of the shadow and the top of the stick. He has admitted that, right?
yeah.
Okay.
Yeah, but that's not
Now,
just an
that means-
elevation angle.
Hold on. Yeah, I know, but that's the next part of it. Because you've established your baseline now.
No, we've
shadow
just established
was
a
your
baseline, not the ground shape.
No, yeah, you have.
Oh,
Yeah, you
what do you
have.
think?
How?
Hold on,
You-
Anthony. What do you think a baseline is? What is a baseline?
A baseline is just your datum point from which an angle can be measured in this case.
And where's it being measured from
Exactly.
and to? Hold on. And where's it being measured from and to?
Well, the turtle's back to the
No.
stick on
No.
anything.
See,
It can be measured
no,
from
no.
anything. We've got two arbitrary positions, or two arbitrary lines that we call an angle.
Right.
But that's not an angle, what you're describing.
It is.
No.
Two
No,
straight lines measured
let
with
Nathan.
stick.
No. Go back
I know
to
what the problem is.
Nathan. Because Nathan, go ahead, Nathan.
Got two
Because we're talking
geographical
about the
locations.
elevation profile. It's not a shape, bro. It's in
Yeah.
relation to the horizontal plane of the ground, starting from a 0 point
Precisely, Eli.
to profile.
Exactly. And you're measuring it between two geographical locations. And what John's trying to lead you to say is once you've established a baseline, you're then drawing a straight line along the ground to the well 500 miles away.
Yeah,
That's
straight
along the
line.
ground.
It bears no resemblance to the ground below it.
That's what you're measuring.
No, you're measuring a line, not the ground.
No, Anthony.
A line along the ground, a baseline.
Yeah, but the line is arbitrary. It is a straight line, but it doesn't mean it's the terrain.
So the shadow's not on the terrain then.
It might be on the terrain.
And the well's not
doesn't
on the
mean that
terrain.
you're measuring the terrain.
Well, then, Anthony, your argument is with this process. Now, regardless of whether or not you disagree with whether or not the arbitrary angle measurement is along the surface or isn't, that is how it's being geometrically defined. So you're arguing against the process like it matters to me. I don't care. That's how it was done, geometrically measured along the ground. Whether or not you say, oh, I don't care, I don't think that's right. Okay, no offence, Anthony, you are but one man. This is how it was done.
Anthony,
Anthony,
Anthony, hang on, Anthony.
I'm just pointing
Anthony,
out
what-
the non sequitur fallacy to think that
Anthony.
the line is the terrain because it doesn't follow.
Anthony,
Not
Anthony,
our
please
non
listen.
sequitur fallacy. It's the rhetoric they used to establish the surface to get an angle. That's what was done according to the rhetoric.
Oh, no, listen, this is the topography argument.
on.
Just because there's hills and valleys, it's not flat. That's what he's doing right now. It's the topography argument.
Yes.
I got it now.
Yes,
Yeah,
that's what.
Can I go after 10th?
Thank you, Brian.
You can,
Plus,
Brian, hold on. After 10th, and after this super chat gets read out from Mike Jones. Also, you are going to give them a celestial sphere as well, Nathan, question mark. Who measured celestial as a sphere? No, that's a misapprehension
Tim
about...
Osman.
That's a misapprehension about what's being described in terms of the celestial sphere. You're measuring it with parallel zeniths, Mike. So it seems clear from your super chat that you don't actually understand how this process is done with parallel zeniths. That would give you a flat roof, as Brian would describe it. So while your perspective view of something moving away from you and moving towards the horizon could be described in an arc, but that's because you're getting two straight line angle measurements to it. The arc would be of the device you're measuring it with, the protractor or the sextant. Yeah, that's how the sextant was named. Well, that angle or arc isn't the arc of the heavens above your head. You've got a linear relationship with perspective with 1 degree every 69 nautical miles. Well, that relationship is along a straight line above your head, a flat roof. So there is no celestial sphere. Your misapprehensions of how this works is what you're displaying there, Mike. Thank you for the super chat, though. Really appreciate the support. Go ahead. 10th, then Brian.
Yeah. When you're using the marine sextant, you're aiming it at the horizon, and you do dip correction. Why do you need to do dip correction, Anthony? Your argument, you wouldn't need to do it. But using the sextant with the Earth's horizon, height of eye must get to sea level to create that baseline, that 90. So you're wrong.
Yeah, Anthony, where you're going wrong is the difference between any random angle and an elevation angle. If I take a 60-degree elevation angle to a star over the horizon, then I subtract that from 90 to get 30. So I know then that 30 degrees that's left over from the 60-degree elevation angle is then the roof of my zenith angle. It's also known as a depression angle in geometry. I multiply that 30 then by 60 to get my nautical, which is 1,800, right, to get my nautical mile distance. But first that 1,800 becomes minutes of degree, a straight line across the sky between two parallel zeniths. That straight line across the sky between those two parallel zeniths must match down at the bottom of those parallel zeniths because they're parallel. Whereas what you're talking about with turtle shells and stuff like that is diverging zeniths. So that distance in minutes of degree can never go 1 for 1 as nautical miles. So if the process, the point is that to do the process of using elevation angles, what you're really looking for, well, not what you're looking for, but part of what you're looking for is the multiplication of the zenith angle. And that gives you your distance across the sky that's then transferred down 1 for 1, 1 minute of degree for 1 nautical mile along the surface of Earth. The Earth cannot be curved for that to work because that will diverge the zeniths. There is no way around that. Now, you can do that on the sea and put your baseline, the height of eye, onto the sea, right? And that means you have a straight line along the surface of the sea, which is geometric straight line along the surface of the sea for whatever distance, right, you get from your angle. But the same thing is happening in the sticks and shadows, but you just don't need to do height of eye correction because it's already, the vertex is already on the ground. You're already on the vertex of the angle is already on the ground, and the GP is 500 miles away. So that means the baseline of that angle is traveling for 500 miles. And that's what Eratosthenes proved, and that's what he measured. And it's after this fact you add R. And for Mike Jones, the celestial sphere doesn't exist. It's a perspective thing. You need to think about divergent zeniths and parallel zeniths too.
Right. With that, sorry to cut you off, I'm going to say a huge, massive, enormous thank you first and foremost to all of you in the live chat for smashing the super chat, liking, commenting, sharing, subscribing, and all that good stuff. Stay tuned if you're watching on either premiering stream, as there will be an after show to follow. Another massive thank you to today's Discord and G+ panels for making today's live show possible. I've been Nathan Oakley. Stay tuned if you're watching on a premiering stream, and I will see you all in the next video.
what a day! What a lovely day!